Okay, so in this video, we are going to go over some more examples of kind of what we are looking for. So identify if each table, equation, or real world example is linear, quadratic, or exponential. And I'm going to want you to explain why. Okay. So, it's easiest to check if they are linear first for tables. So, if they are linear, remember back from our introduction video that they are going to have a constant adding or subtracting rate in both the x or y values. So, just looking at my x values, so this, to get from 2 to 3, I'm adding 1. Adding 1, adding 1, and I add 1. Make sure that you check all the way down because some of your questions on your homework might try to trick you. Okay, and to get from -5 to 1, I added 6, add 6, add 6, and add 6. So this in fact is constant in both the x and y values, so making this one linear. And it is linear because there is a constant adding rate in both the x and y values. And make sure that you have adding there because remember multiplication is exponential, so you don't want to confuse the two. Okay, number 2. So if I look at my x values for number 2, because again, let's start by checking if they are linear. So I added 1, and I add 1, I add 1, and I add 1. So here, I add 3, but then I have to add 12 to get from 4 to 16. So I can already tell you that this is no longer an option of being linear. So we're not going to want this there. Okay. So next easiest one to check is if it is quadratic, which remember those values are going to mirror each other after some point. So if I pick a point on here, usually it's the middle one, not always. So again, be careful with your homework. So if I look at this middle point here, and I were to look at the two surrounding it, are those the same? And in this case, they are not. So it's not quadratic. So my next thing then to check is exponential. So I know that exponential has a multiplication rate. So if I multiply 1 by 4, I'm going to get 4. So this needs to be the same. So if I multiply 4 by 4, I am going to get 16. And then 16 times 4 is 64. And 64 times 4 is 256. So this, in fact, then is exponential. Because the y values have a constant multiply rate of 4. So again, make sure that you say that this one is being multiplied, because if you you could get it confused with the adding that linear has to be. Okay. Then number 3. So we've already talked about linear and we've already talked about exponential, which automatically, just to give you an example of all of them, this one is going to be quadratic. So quadratic is what we were talking about in this one, where you have to have a point and then your y values mirror around that point. So in this case, it is the middle point, but be careful again on your homework, because that won't always be the middle point. So then around it, see how these y values are the same? And then these y values are the same. So that's what they mean by mirror. So this one is quadratic because the y values mirror each other. Okay, so there were our examples of the different tables. Okay, so now let's get into some examples of graphs, which these are by far the easiest ones to kind of go over. So just looking at this graph, I know that this one is going to be quadratic. And then again, you have to explain why. So this is a U-shaped graph. Which, if you remember from that introduction video, we talked about the different shapes. So, and actually this one is an N, not a U, but you understand what I'm saying, which makes this one quadratic. Okay, we move on to the next page. So then we've got this graph up here, which is linear. And all that you have to say is that's because it's a straight line. We will end up having to get a little bit more in detail about these, but for right now, that's all the information that we need. And then lastly, this one is exponential. And that is because this one doesn't cross the x-axis. Okay. So there was an example of the graphs, which, like I said, those are pretty easy to be able to tell what they are by the graph. Okay, so now some story problems. So Ryan is about to make ramen noodles for dinner, but needs to bring a pot of water up to boiling before placing the noodles in it. The temperature of water increases 10 degrees every minute. So if you again remember from our introduction video, so we went over that something is linear if we say the word per. So the word per is in the problem. which in this case it is not. And then for quadratic, it was talking about an object going up and down, which we're not talking about an object going up or down. We're just talking about boiling water, and that's just going up. It's not going up and down. And then exponential has a percent in the problem, which again, this one does not have a percent in the problem. So we need to go back and look at that linear because there could be synonyms of the word per in this sentence here. So if I'm looking at this, the one that you really need to pay attention to is the last sentence. So the temperature of the water increases 10 degrees every minute. So we can replace the word every with per, and that would still make sense. So we could say the temperature of the water increases 10 degrees per minute. And that makes sense. So there we go, making this one linear. So we would say that the temperature increases 10 degrees per minute. So the word per is in the problem. Okay. Tyler kicks a football from ground level at an initial outward velocity of 90 feet per second. How high is the ball at the highest point? Remember, gravity equals 16 feet per second. Do not solve. So here, we are talking about an object, and that object is the football. So that football, we are going to kick up, and then it's going to have to come back down because of gravity. So making this one quadratic. And that is because the football was kicked upwards and must come back down. Okay. Then the last one. So the number of people who own computers has increased 23.2% annually since 1990. If 500,000 people owned a computer in 1990, how many people will own a computer in 2015? So here we have this 23.2%, which makes this one exponential. Because it has a percent, which is that 23.2 in the problem. Okay. So the last three are equations and saying if they're exponential, linear, or quadratic from those. So if I'm looking at this, I see, so we want to pay attention to where our x is. So we've got our x is here in this one, then we've got the x here in that one, and then we've got this, the x squared in this one. So if the x is in the exponent or in the power, that makes this one exponential. That's because the x is in the exponent. Or you could also say that it is in the form of the y equals a b to the x formula. Either one of those options work. Okay, so the second one, we just have an x kind of all by itself. So it's not squared and it's not in the exponent, which means that this one is linear. And there's nothing really to say about linear equations except for the form that it's in. So this one is in the form of y equals mx plus b. Make sure you use the right form. So I put the mx plus b because all of those are present. If it didn't have this plus 8 here, then I would only want to put in the form of y equals mx. So be careful with what form you are writing down. Okay, and lastly, so this one has an x squared, which means that this is going to be quadratic. So there is an x squared is in the equation. So that's one option, or you can say what form it's in. So this one is in the form of y equals a x squared plus bx plus c. So, and I just got those forms from the last video. Okay. So let me know if you have any questions over kind of what I'm looking for these. But we are, like I said, going to get into a little bit more detail as we get going.